So hi everyone, thanks a lot for joining the call. This session is basically a demo session for the system design course that I have planned for July. And in this demo class, I'm going to talk about load balancing. I'll be touching some details about it, but since load balancing is in itself sort of a big topic, so I'll not be going into each and everything since that might take more time. And I have a demo also planned. So considering how much we can cover, I'll try to cover that much because I want to show you some demo also, right? So okay, so let's start. So as load balancing, name suggests, yeah. So as the name suggests, load balancing basically means there's just there are servers that you have, and there are users, and there's a load balancer in
Hello.
between.
Hello.
Yeah,
I'm sorry to interrupt, Udit.
yeah,
Just had a query before beginning.
yeah.
So, are we also going to discuss what is what is going to be the content of the course and details about the course, basically?
So basically, towards the end, we'll see how much time is left, and then we'll try to discuss that. I have planned that also. I'll try to discuss
Acha.
that. But if we sort of we finish the time in the load balancing itself, then I'll try to schedule another session to discuss specifically about course details and all. Is
Okay.
that
So
fine?
this session was specifically for load balancing as such.
Yeah, demo class specifically. So
Okay.
that you
Okay.
will get
Sure.
an idea, like what how you will be getting the learning in the actual course.
Sure. Sure. Okay.
Great. So let's continue. So load balancing, as the name suggests, it's like balancing of load via service, and the service that does this or the balances the load is called a load balancer. So it gets some request and it routes some of the requests to server number one, and it routes another set of requests to server number two. How it does it, why is it required? That's the whole point of this content, right? Let us first see ki why do we need load balancing at all, why do we need such kind of this magic server in between to distribute the load among the servers, right? Yeah, so ensuring so let's say we have a single server which is capable of which is capable of handling four requests. Let's say this is some demo server, or some server which is handling some request. It can be a website server, it can be anything, right? So this server is basically uh, just taking some requests from the users, and let's say this server is capable of taking four requests at a time. So users come in, they make four requests, everything is good. Now let's say the server crashes. What happens to the users? Your users will not be able to get their request fulfilled, right? Like before that, they were able to make those requests to the server. Let's say if it's a website, if it's Amazon.com, the users were able to make the call to Amazon.com, and then they were able to get their whatever the request they want to make, they were able to do that. But now since the server has crashed, our service is sort of down. So the high availability that we tried to achieve, that is sort of lost. Our service is not available at all because the only server that was serving the request is down, right? So that way your service is not available anymore. That's one issue. Another issue is, let's say again you have a single server which is capable of serving four requests again. Four requests come in. Still, again we are good, right? Since the server is capable of handling four requests. Let's say your user base increases. Now you are getting eight requests at a time. That may happen because you incorporate more features into your service, or your service become more popular, right? So anytime when you are building a service, you will try and you will hope that, right, that service becomes more popular. So when the service becomes more popular, you will get more requests. And let's say instead of four requests, now you're getting eight requests. But the server in itself, we said right in the beginning, it is capable of only handling four requests at a time. So your server will crash, right? So these are the two problems that we have to handle the server getting more requests. One of the way you can do it, is upscale your server. Upscaling means either you can increase the RAM of the server. So for example, earlier the server was able to handle only four requests because it has some specific amount of resources. Like if it has 2 GB, each request is taking some memory. So let's say 20 requests were getting filled. So each request was taking, let's say, 100 MB, so 2 GB was getting filled. So you try to increase the RAM of your of your server. So you try to increase 2 GB to 4 GB or maybe 8 GB. Also, you try to increase the CPU, 2 cores to 4 cores maybe. You try to increase the resources on the server, right? So that earlier the request that you were able to handle only four, now you are able to handle eight requests with the same server, right? But can you do this forever? Let's say again your 8 requests becomes 16 requests today, or let's say your 16 request becomes 32 requests, or let's say 1000 requests, or let's say 100,000 requests, or a million requests. Will you be able to increase rams infinitely? Will you be able to increase the CPU infinitely? No, not obviously not, right? Because you will have some limitation at some point of time. Like, let's say you increase to ram to 128 GB or something, like, some supercomputer kind of thing, but still you will have some limit at that point. And at that point, you either say no to rest of the users, or you will say, like, you will have to figure out some solution of it. So upscaling the server is not the actual solution to handle the increased load. Okay. Actually, I'm getting this. Yeah. Great. So what's the solution then? What do you guys think? What can be the solution? And can anyone think about any solution? Increase servers. Horizontal scaling makes more servers. Correct. So as the people are suggesting, we have to increase more servers, right? Like, we have, let's say, instead of one server, we have, let's say, two servers, and each server is capable of handling four requests at a time. Now, how does this solve both the problems? We have two problems that we have seen so far. One is high availability, and second is scalability. High availability was when we were not able to, when our server was down, over here, right? When our server was down, then the user were not able to get the request fulfilled. So that was not high availability, right? And that's the scalability, the second part, where when the load on our server increased, still we were not able to scale the server. So these are the two problems, and to fix those two problems, one of the solution is, let's say, we increase the number of servers. So let's say we have server number one, server number two, and some user comes, when they come online, they join server number one, and some user, when they come online, they join server number two. Okay. And each server is able to handle four requests at a time. And let's say, now how does it solve both the problems? Let's say server number one goes down, but server number two is still there, right? So we will keep serving our request. And let's say our number of users increases. Let's say they increase at this time, so we increase from server number, instead of one server, we increase to two servers. We are good, right? But there are actually multiple issues. What do you think can be the issues over here? There are multiple issues actually. Transfer of data. What kind of data are you? Let's say there is no data. Let's say it's just a hello world application. Let's say there is a single API which you hits and it returns you hello world. Let's say it's just that. How to divide the load? Okay, redundancy. In multiple servers, syncing is slow. What sort of sync? There is no syncing, right? Like, each of the server is independent, and each of the server is independently getting the load. We do not have data, so there's no state, per se, because of which you might face some issues. So syncing is not the issue over here. Some servers might be idle. True. These are actually the issues, but the main issue is, how will your client know which server they should connect to? Like, you have just two plain servers, and let's say there is a third user coming in, and you have two servers. How will your third user will know, should I connect to server number one or should I connect to server number two? That's one issue. Another issue is, what if, let's say, one server goes down? Like, let's say again server number one goes down, still you have server number two serving some of the requests, but the users who were connected to server number one, they're still seeing the service as down, right? You are able to fulfill half of the users, but for half of the users, the service is still down. So we tried to increase the number of servers, but still there are multiple issues, as you see. Other issues, which people also pointed out, like, distribution of load. Let's say your server number one and server number two servers are there, and one server is capable to actually handle more load than the other one, but still you are relying on users to pick one of the servers to connect to one of them. Like, instead of that, you would want yourself to decide which user should connect to which server, because that way you can distribute the load more strategically, or more intelligently. Like, I want the server which is handling more load, more number of users should connect to it. So as you can see, like, there are multiple issues still. It's a very fragile system. If one server goes down, still your users, half of the users are facing issues. If new users join in, still those new users are not able to get the request fulfilled, right? So how do we fix this then?
Uh, there's one point.
Yeah.
Like in the first point, you told that how a new user know. So that for that solution is already there, right? We use virtual IP in that case.
But we have not used any virtual IP in here, right? There's just two servers,
Hmm.
which is server number one and server number two. Each have their own IPs, IP number one, IP number two, and each of
Right.
the user get one of the IP. Let's say user number one get IP number one, user number two gets IP number two, and user number one connects to IP number one, and user number two connects to IP number two. If one server goes down, let's say IP number one goes down, the user is not getting the issue resolved, right? I mean, the request will fail for user number one. And let's say you use the virtual IP concept, but then in that case you still have only single server serving at a time, right? Virtual IP takes comes into picture when you have sort of backup servers in place, but here you are not using backup servers. Let's not go into backup servers in detail, because that requires a different session altogether. But virtual IP will not solve the issue. As you can see, like, that IP will, first of all, that IP will get assigned to only single server, so your other server will remain idle in that case, so you will not be able to scale in that case, though you will be highly available, but you will not be able to scale. And the second problem is, your users are not actually getting the virtual IP, they are actually getting the IP of the server. Does that make sense?
Okay.
So what do you think can be the solution here? We saw there are multiple problems in between, right? Like redundancy, or load distribution, one server going down, how the users will discover the servers. So that's actually the load balancer. That's actually the work of load balancer, right? Um, you have Load balancer is just nothing. It's a service in between your users and your servers. And instead of your users connecting directly to servers, they first connect to load balancer, and then load balancer decides which server should serve that request. Like, let's take an example of a restaurant. When you go to a restaurant, you don't directly go to the chefs, right? Like, let's say you make some request. Let's say there are five users coming to restaurant, and you all the five users will go to the reception, right? And then reception guy will decide, like, which chef is right now free, and based on that, whichever chef is free as per the reception guy, that request will be sent to that particular chef. Number of chefs can anytime increase, number of chefs can anytime reduce, but it's all the responsibility of the reception guy to distribute the request among the chefs. That's the exact role of load balancer over here. Instead of your users directly going to chefs, which are servers in our case, they are actually going to the receptionist, which is, or the guy who sits at the front, which actually takes the request and then decides, okay, I have like these five servers, four servers, or two servers with me, and let me decide which server is going to serve this particular user. Now the two problems that we had earlier, like, these two problems, which how would the new user know which server it should connect to, and what if the one server goes down? In both the cases here, the users are not connecting to servers, so they are connecting to load balancer directly, so they will not care about if which server they should connect to. There will be a single IP which they will be connecting to. Again, if one of the server goes down, then load balancer will itself take care of it, and users will not be impacted, right? So that's the actual role of load balancer. It is taking load from the users, and then it is transferring that load to the backend servers. Any doubts so far? Yeah. What if the load balancer goes down? We'll come to that later on. That's there in the discussion.
So basically, the user will only know the IP of the load balancer.
Users will only know the IP of the load balancer. Correct. Is the load balancer sort of a queue? No, load balancer is not sort of a queue. It is like, you can treat it like a middleware service, which is actually taking request and then forwarding it to the server. It is not, though basically there is one more thing which is called reverse proxy. Sometimes load balancers work as a reverse proxy also, and at that point of time they can buffer some request. But that's just an additional responsibility which load balancer serves when they work as reverse proxy. But in this, from the point of load balancing, load balancer does not use any queue or something. It just take the request, forwards them to server, gets the response back from the server, and returns it back to the users. Is there only a single load balancer for the system? So basically, single service will have a single load balancer and a backup load balancer. If you have 10 services in your system, then you might have single load balancer serving multiple services, or each service can have its own load balancer. But but in a single service, since the load balancer can become a single point of failure, which we'll come to it later on, we'll need backup load balancer, and we'll see how that thing fits into the picture. But yeah, each service has its own load balancer in general, practically when you work in a production level system, and each load balancer has its backup load balancer, whatever service is more popular. So basically, if even load balancer is becoming your single point of failure or is getting more load, then you use load balancing via DNS, which again will come later on. Any other questions? Any more questions on this? And if anyone has not understood anything, then also he or she should point out. Like, it's more important for you to understand everything what we have discussed so far. When the backup load balancer comes up, does it get the same public IP? Yes, it will get the same public IP, and that happens via virtual IP. We'll come to it at the end. Is load balancer set up on different machine altogether? Yeah, load balancer is a different machine altogether. I mean, if you're using cloud, you are actually not sure if it's a different machine altogether or not, but it's definitely a different VM. So from a client perspective, if you're using some cloud like AWS or Azure, then load balancer is actually on a different machine. Like we have shown in the PPT also, there are two servers which are running, and there is a different machine or different VM altogether which is serving the purpose of load balancer. Okay, so let's move forward. So what we have discussed so far, some of the features of load balancer, like when you are using load balancer, you are giving faster and uninterrupted service to the user. Your users are not interrupted in any way. If one of the server goes down, then other servers will take up the responsibility. So you are actually serving your service uninterruptibly. You have high reliability now and higher availability, because again some of the servers goes down, then still you are able to serve your request. You are now able to scale easily more, because as depending on the load, you can include more number of servers, and if you are seeing you are going to have less number of users, then you can reduce the number of servers, and load balancer will automatically divide the load among the servers which are right now available in the service, right? Again, one more thing which additionally load balancer does is it keeps tracks of the services health, and also the latencies to give best performance to the users. We'll come to the server health checking in a minute. Okay, so these are the features of the load balancer which we have already discussed, except health check. We'll discuss health check now. So one point which might come to which might come in mind, which might come in all of us, like how load
Udit,
balancer.
there is one doubt.
Yeah,
Like in the last slide, you told about scalability. If you could switch to the slide once.
yeah.
Yeah. So you told ease of scale out and scale in. In case of load balancer, we still, I mean, scalability that we talked about is either horizontal or vertical. Here, how load balancing helped in scalability? Because if there are two or three machines on the back end,
Mm-hmm.
and we have a load balancer now,
Mm-hmm.
so at the most what we have done is like you told कि user switch कर सकता है उसको पता मतलब that responsibility is not left to the user, so switching हो जाएगा, but scalability कैसे benefit हुआ
So
होगा
basically,
वहाँ
let's say your each of the server is able to handle 4 requests right now, right?
पे?
Let's take this as an example. Let's say you load tested your server and you found like each of the server is able to handle only 4 requests. So now we have two servers. So overall number of requests that you can serve is 8 at a time, right? Let's say now you
Mm-hmm.
see कि you are already at 6 requests per second or six requests at a time, and now you want to scale out or add more servers to the system. So you will just increase the number of servers over here, server number one, server number two, and there will be one more server coming up, or maybe two servers coming up depending on your scale out policy. Server number three or server number four, and they will also attach themselves to load balancer. And now load balancer will be able to, or your whole system will be able to handle actually 16 requests at a time.
Right. Right.
Did that clear your doubt?
Yeah. So scale out is increasing the number of servers,
Exactly.
right?
Scale out actually means increasing the number of servers, and scale in actually means reducing the number of servers.
Okay. Okay. So earlier we couldn't do this.
Yeah,
So
you
supposing
couldn't
we
do
got
this because you how would you let your users discover more number of servers?
right, right, right.
Let's say you put
Okay.
four more servers. How would your users know, like which server they should connect to? So
Yeah.
load balancer is actually helping you in that.
Right. Got it.
Okay, cool. So let's move forward. So, let's say we have four servers or two servers in the backend, but like the $1 million question comes in: which server should the load balancer sends a request, and how does it choose that server, right? So there are two things which load balancer uses to choose a server for a particular request. One is the healthy server. Since that looks like a very obvious thing, right? Like a load balancer, when it is sending a request to some backend server, it should choose a server which is a healthy server, right? I mean, if a load balancer sends a request to a server which is not healthy, or which is itself is crashed, then there is no point sending a request to that server, right? Because if a load balancer sends to a crashed server or unhealthy server, then he will not get the response back from it. So one of the thing that it does is it chooses only the healthy server. We'll see how load balancer decides whether a single server is healthy or not. That we'll check in a minute. But the first point which load balancer uses to decide which server it should forward the request to is the healthy server. The second thing is the load balancing algorithm. So there are some pre-configured rules of load balancing which load balancer uses to decide one of the server. So let's say there are 10 servers in a healthy pool. So let's say you have 20 servers overall. Let's say 10 servers are unhealthy and 10 servers are healthy. So from your 10 healthy servers, which got filtered in the first check itself, right? Now you have 10 healthy server pool. In those healthy servers, load balancer will choose one of them, and that is done using a load balancing algorithm. Most popular load balancing algorithm is round robin. So let's come to the load balancing algorithm. So round robin algorithm means, like, if you have a load balancer, if you have four servers, request will be served sequentially, or request will be given to each of the servers sequentially. So it will first start from the first server. Request first comes in, the first server will be chosen first. Request 2 comes in, second server will be chosen second, then third, then fourth. Okay. Similarly, next request comes in, again server number 1 gets chosen. So again request comes in, server number 2 is chosen. So this way, round robin simply means that choose one server after another, and when you are done with the servers, go back to the server number one again. That's a very straightforward way, and that's the most popular way in the backend that is used. You just deploy the round robin approach. So in this case, load balancer does nothing. It just takes the ordering. It just maintains some ordering of the servers, and using that ordering, it will keep on sending the request from one server to another. Not from one server to another. First to the server number one, then to the server number two. Second popular approach is least connection. Over here, this type of actually approach is more popular when you have different types of backend servers. So let's say some servers are able to handle more load, some servers able to handle less load. So you will want to redirect your request to those servers which are actually handling less load right now, right? So for example, server number 2 is already handling 3 requests right now, and server number 1 is actually handling 2 requests, and server number 3 and 4 are handling only 1 request. So what's the point of sending more requests to server number 2, right? Because server number 2 is already loaded, and you would not want to load server number 2 even more, right? So when the new request comes in, the load balancer will send the request to server number 3. Again, the new request comes in, the load balancer will send the request to server number 4. So at each time, the load balancer will choose the server which is least loaded right now. That's the whole point of using least connection. Next type of thing is least response time. I mean, the two that we have seen, round robin and least connection, these are the most popular ones. There are two others also, which is called least response time. In this case, the load balancer will keep track of what's the response time it is getting from each of the servers, and then it will choose the server which is showing the least response time. Again, the source, let's skip that because that is more important mostly for stateful request. And in the interest of time, I think we should not discuss about stateful servers. We are only discussing about stateless servers. So let's skip source for now. So what we know so far, till now we know what's the load balancer, why is it needed, features of load balancer, how does it work, and how does it pick a server to server request. One thing which we missed is how does load balancer find out whether a single server is healthy or not, right? There are two ways to it. First way is load balancer has something called health checks. Each of the server, when you are attaching each of the server, when it itself attaches to the load balancer, it has to provide one endpoint to the load balancer, which load balancer can poll after every interval, so that load balancer will know that the server is healthy. So what load balancer does is, let's say load balancer has two servers at the backend. Load balancer will keep on giving or firing some health check request to each of the servers after every some time. Let's say 2 seconds, 3 seconds, 5 seconds, whatever amount of time you configure. And if any of the servers does not respond, then the load balancer will think that the server is not healthy and it will remove it from the backend servers. Right. So that's the one way of how load balancer keeps track of healthy servers. Second way is your in-flight request. Let's say you have configured 5 seconds as your interval of health checks, and your request comes in at third second, let's say, right? And that request fails because your backend server is down. Then again, let's say fourth request comes in, but load balancer will know since the third request failed from that server, so that means that server is actually unhealthy. So it will not wait for the health check, and it will use the responses from the previous servers to judge that the server is unhealthy, and it will not send a further request to it. So that these are the two ways by which the load balancer will decide if a server is healthy or not. Okay, so any doubts so far? We have almost covered how load balancing works, what is it, features, and how does it pick the request.
There are two doubts with it. One is you told about least response time. Why would load balancer select the server which will respond in the least time? It would select one with the highest response time, right?
No, least response time will give you the best performance, right? So let's say if one server is responding you in 100 milliseconds and another server is responding you in 500
Acha, acha, acha,
milliseconds.
acha. Okay, that way. Okay. Yeah, yeah.
Did you get
Got
the
it.
point?
And yeah, yeah, yeah.
Okay,
I got
okay.
it. And other doubt was regarding the first way of checking the health. Could you repeat that once, please?
Yeah. I mean, first way, do not have a slide
Of
on it, but
checking.
yeah, I just have
Yeah, yeah.
this.
You. Yeah.
Yeah, yeah.
Yeah. So you mentioned two ways of checking the health. So second point I got it. First point I did not get.
Okay, so basically, first point is, let's say there are no requests coming in between. So the second way was when the requests are actually coming in, and if some of the actual requests fail, then load balancer is coming to know the some of the backend servers are not healthy. Um, but what if, let's say, there are no requests coming in to the load balancer? So load balancer itself generates some requests after every some seconds. Let's say it's actually a polling mechanism which load balancer uses, and it polls each of the backend servers and tries to make a health check request. And if some of the backend servers do not respond, then it will consider that those backend servers are not healthy.
Okay.
Any other doubts?
Yeah, there was one other doubt. Like you told about switching, the how user will switch if if it is already getting served on one server and if that server goes down, how it will switch to the another server. So
So load balancer maintains a pool of healthy servers, and if any of the server goes down, then it will remove that server from its healthy pool. So the further requests that come in, that healthy pool will not have that server, and thus load balancer will not send the request to the unhealthy server.
and what about the request that was already getting served by a particular server?
Those actually, that will depend on the type of load balancer. Some load balancer retry requests on their own, and some load balancer just fail the request at the user end. But if the user retry, then they will then they will get the request fulfilled.
Okay. So that initiation of request has to happen from load balancer, not from the user again, right?
No. So that depends on a type of load balancer. Some load balancer retry on themselves, but those are very complex load balancer. In general, if you see all the users who are who were getting served or the requests that were getting served, though they will definitely fail at that point of time, because retrying on load balancer is not needed in most of the practical applications. In actually 99% applications, you will not need retries on load balancer.
Okay. So, for example, if my session, if I'm logged in somewhere and this something like this happens, server goes down, so I'll have to re-log in basically.
No. So that's the state. Your state is not maintained in a server, right? Your state will be maintained some like something like cache or something. So you will not have to relog in. It will be just like, if let's say you are, let's say Amazon.com. Let's say you hit Amazon.com, and your first request fail. You just try to reload and it works. Then that's all it will happen.
Achha. Okay. Okay. Thank you.
Did that answer you? Did I answer your question?
Yeah, yeah, yeah.
Okay.
You answered it. Yes.
Okay. When the load balancer, sorry, let me just check. Sorry, I missed the chat. A system can have more IB for a system depending upon services provided. Then we type a URL. Then does we get a single IP for the list? We get a list of IP actually. So basically, in general, in the actual production systems, you will not have a single you will actually not have a single data center in all. You will have multiple data centers or multiple availability zones of your service. Since availability zones in data centers are out of the scope of this topic, so I'll not go into very much detail about it, but I'll just tell you a bit about it since you asked. So in the DNS, where you configure the domain name to the IP, you will put the IPs of multiple data centers. That will help you in two ways. One way is if one data, I mean, DNS will provide some sort of load balancing at their end, because it will DNS again will give the IPs on round robin basis. And if one data center fails, then some actually browsers have this thing inbuilt into them ki if they get multiple IPs from the DNS, then if first IP fails, then they will retry on the second IP automatically. So that will help in second way also. So actually, in general, even if try to find the IP addresses of google.com, it will give you a list of IPs from the DNS. Health is determined by heartbeat mechanisms, right? So each of the load balancer, either you call it heartbeat or you call it health check, these are the same words, but each of the load balancer will be doing a health check after every some time. And then it will decide like which server responds, and if some servers do not respond, then it will consider them as unhealthy. Let's say frequency of polling is every 5 seconds, and if one server fails at 6 seconds, for the request process to the field server. So basically, let's say if one server fails at the 6 second, then that request will fail. But all the further request from that 6 second to 10th second, those requests will not be sent to the server, because load balancer will use this information that in-flight request or a live request to a server actually failed, and it will then not send more requests to the failed server until it comes back or becomes healthy again. So load balancer will keep on doing health checks to that failed server, but will not send the live request to it. And once the health checks start passing again, then it will start sending the more requests to it. I hope I answered all the questions.
Yeah, Udit, there's one other doubt. Like health heartbeat mechanism is nothing but if you know on Linux we have Pulse software. So is that the same thing?
I am not sure about Pulse. What is Pulse? But yeah, in general, health check is just like periodically sending a request to the backend servers. That's all. I will actually show you in the demo. I have a demo
Okay.
planned. So in the demo, I will show you how the health check comes.
And what is frequency of pooling?
That's configurable at the load balancer. You can keep it 2 seconds, 5 seconds. That depends on the type of application that you are building. If you want to fail fast, then you will keep it short. If you want to, reduce the number of health checks that you're getting at the service, then you will keep it large.
Okay. So frequency of pooling is the frequency at which the health check happens.
Correct.
Okay.
How about other guys? Are you guys following, or have you guys completely lost, or I want to understand, like, um, were the concepts clear? That the concepts that we have discussed so far, are they clear, or are there some doubts? Cool. Great. So let's move forward. Just feel free to ask any doubts anytime. Okay, like there is no doubt which is bad or good. So I would expect every one of you to keep asking doubts whenever you get it. So now, as some of you already pointed out during the when we were discussing earlier, like is load balancer a single point of se- oh, it should be an F, single point of failure now. Like earlier we have a single server. When we started, if you remember, we had a single server, and if that server failed, we were not able to handle the request from the users, right? If you see clearly, we had sort of created the same problem for us again, right? We had created two servers at the backend, but still there is a single load balancer. What if this load balancer goes down? Where will the users connect to? What do you think, guys? I mean, what will happen? Are you getting my point? Like, we have replicated the same problem, but a step before. Earlier, the problem was happening at the backend servers, which are blue color right now. Now we have replicated the same problem at red color server, right? Like, we have a single load balancer, and if it goes down, everything goes down. Multiple load balancers, correct? But how do you load balance among load balancers then? Will you put another load balancer between the two load balancers? Again, that new load balancer that you will put between the two load balancers will become a single point of failure, right? DNS is one way, correct? But DNS, let's say you have two load balancers and you are using DNS for it, and one of the load balancer goes down, but some of the users will get the same IP, right? And it takes some time for DNS propagation to happen first, and second, it takes some time for users to get to fetch new DNS because every DNS has some TTL. So DNS refresh will create or will make some users not get to your system for some amount of time. Master slave architecture, right? That will actually solve the problem. Multi-level of load balancer like a tree. I'm not sure what do you mean by multi-level of load balancer like a tree. Can you just tell? I mean, talk about it by unmuting yourself. If you mean tree like first load balancer, then two load balancers, then four load balancers, um, then it's not gonna working because still you will have a single point of failure. Like one at top, like it's okay. Okay. So actually there are two ways. One is as some people pointed out, like DNS. Another, yeah, correct. Multiple load balancers may be in active passive mode. Exactly. So there are two ways to it. One is the DNS and one is active passive load balancer. DNS, since it is very much unreliable, you never know when the DNS propagation will happen. If let's say you have multiple IPs, still you will you will actually highly relying on clients to make use of multiple IPs, right? In that case, let's say you have two load balancer or maybe four load balancers, and you give multiple IPs to the clients, then you are actually relying on clients to use multiple IPs or fall back to a different IP from the DNS when they are when one of the load balancer goes down. So another way which actually most of the cloud providers provide these days is you can use virtual IPs or also called as floating IPs. Since floating IPs is just nothing, you can assign the same IP to multiple servers, but one at a time. I mean, it cannot be like you assign the same IP to the multiple servers at a time. So that IP can be assigned to first server number one, server number two, depending on whichever you want to assign it. So you will keep two load balancers. One is load balancer one is another one is load balancer two. You will keep serving your request from the load balancer one. That will be called as active load balancer. And whenever that load balancer goes down, the load balancer number two will come into picture, and then it will be it the earlier it was the passive load balancer, now it will become the active load balancer, and that virtual IP will get assigned to this passive load balancer. So you will not see the IP change, but still you have changed the box from the backend, right? So that's the way you will actually would like to make your public facing load balancer to have the IP. Is that clear?
Adit, I would not understand how that switch was made in
That switch is
actual.
actually configurable at the cloud provider only. So basically, that virtual IP, you will provide two IPs to it, which are the
Mhm.
IPs of the active and passive load balancer. And if one load balancer goes down, the passive one will come up, and it will take that virtual IP by itself. So there are actually APIs provided by cloud providers for that.
So one of the machines will have a physical IP and a virtual IP.
Correct. I mean, each of the machine will have the two load balancers will have each will have one physical IP and one virtual IP. Passive load balancer will not have a virtual IP because at that time that virtual IP is actually assigned to active load balancer. But yeah,
Right. And how is floating IP different from virtual IP?
it's same. It's same. Virtual IP is I mean, floating IP is just a new name in cloud to the virtual IP.
Okay. And could you please re-explain how DNS uh, was a con, basically DNS
So
propagation?
let's say you have google.com or let's say amazon.com and you have IP number one, right? Let's say IP one is the current IP to the load balancer. Let's say there are two
Okay.
load balancers you have. One is IP number one, IP number two. Currently in the
Okay.
DNS, you have IP number one since it is working fine. Now
Okay.
your somehow your load balancer fails. Your backup load balancer come into picture and it makes a request to the DNS record like change the IP of service or the domain to my IP now. So the
Okay.
google.com or amazon.com changes to IP number two, but that
Okay.
change to propagate to the complete world, right, to the users, actually it will take some time because DNS propagation does not happen instantaneously. It takes some time for DNS to propagate to the server which your users are actually using. And even if it propagates to the nearest server which your users are using, then also there is a TTL for which a DNS record is valid. So for example, TTL, let's say if you keep it as 5 minutes or something, then also even if you have changed the IPs, your users will not see the refreshed IP because they have cached the DNS records for 5 minutes. So they will keep on seeing the old IP until the DNS refreshes.
Okay. सो बेसिकली ऐसे नहीं होता है क्या कि डीएनएस में दोनों लोड बैलेंसर की एंट्रीज हो और फिर एक एक पे अगर पॉसिबल रिक्वेस्ट रिस्पांस ना आ रहा हो तो दूसरे पे जाए
But what if,
इट
let's
डज
say,
नॉट.
your client sees only one IP and it just makes requests on that? It doesn't uses the round robin on itself.
Client is only typing google.com or
That's
amazon.com,
how
right?
your browsers are working, right? Like, what if you have a custom app you are building and you are connecting to some API in the backend, and then the client that you are using, an HTTP client that does not do the round robin of the IPs.
अच्छा. Okay.
So the whole point is like we do not want to rely on DNS for failover, since we already have a mechanism of virtual IP. So for DNS, we are actually using for balancing load among the data centers. For failover, we are not relying on DNS because DNS itself is not reliable, right?
Okay.
Is it clear?
Yes, yes.
Cool. I actually did not want to cover this, so that's why I had not created slides on it. But yeah, so I thought you guys will be taking as the next things to learn yourself. But yeah, we discussed it anyway, so that's not an issue. So the next things which you guys, or when we have actual classes in the course, then we will discuss these. The scaling that we have, or the load balancing that we have discussed, is only the scaling or load balancing of stateless servers, when each of the server is identical and request can go to any one of them. We did not consider stateful servers actually. Load balancing or scaling of stateful servers happen in a completely different way, using consistent hashing and all. Partitioning, sharding are the concepts which are applied for stateful servers. So that's something which we should discuss next. Then we did not discuss about reverse proxy. I mean, load balancer sometimes, or most of the times, actually in all the production scenarios when you work in a company, then you actually use a reverse proxy. So how does load balancer differs from a reverse proxy? Because same service like HA proxy works both as a load balancer and reverse proxy, and there are very subtle differences between them. So what are they and when will you use one of them? That's not discussed today. Types of load balancers today, most of the load balancers that you see, that are L7 load balancers, and you will be mostly good with them. But earlier there were something called L4 load balancer also were also popular, and what are they? We did not discuss about them. So that's again will be not that's something not discussed in this class, in this session, but we'll discuss it in the course. Any questions, and or I will go to the demo. Not questions on these. How would yeah, Abhishek, the session is getting recorded, and we'll send you the link. How would the active passive load balancers switch if we were to set up outside of cloud provider, like if it was a physical? So in that case, there is concept of virtual IP, which actually these cloud providers also use. So that virtual IP you can actually include in your local setup also. Cool. So let's come to the demo.